Welcome to The Explainer. Grab your lab coats, folks, because today I'm putting on my planetary geologist hat and we're stepping right into the lab to look at a genuinely groundbreaking discovery. We're talking about a Martian meteorite called NWA 8171. Now, this rock has actually been sitting quietly in the Royal Ontario Museum's collection for a while. But scientists recently cracked open a tiny fragment of it and found an absolute treasure hidden inside. It's a mystery that literally has the entire planetary science community buzzing right now.
You know, when we talk about paradigm-shifting, planetary breakthroughs, we usually picture massive rovers, right? Or deep craters, giant canyons. But our subject today, it measures just 0.8 by 0.5 millimeters. To put that into perspective, that is smaller than a single poppy seed. And yet, within this microscopic fragment, researchers found something that had never, ever been seen before in a Martian sample.
So, we gotta ask, how could a speck this tiny rewrite the history of Mars? Well, think of this explainer as a bit of a scientific detective story. We have a microscopic grain of a previously undiscovered mineral from Mars, sitting right here on Earth. If we can just decode the clues locked inside this tiny speck, it could completely change our understanding of an entire planet's geological evolution. But to understand how it changes everything, we first need to figure out how it managed to go unnoticed for so long.
Section 1. The Great Garnet Disguise.
Okay, so finding garnet in a Martian meteorite is an absolute first. And honestly, a big reason it hid for so long is that it doesn't look like what you'd expect. When we think of Earth garnets, we picture that classic gemstone, right? Glowing with this deep, blood-red hue. But the Martian version? It's an iron-rich form called andradite, and it completely trades that red for a tricky, yellowy-greeny, almost olive tone.
And because of this olive color, it camouflaged perfectly among other super common meteorite minerals. So the team staring at this tiny cross-section faced a really crucial question. Are we just looking at standard pyroxene, or is this actually garnet?
Planetary geologist Tanya Kozowski from Brock University and her team noticed the chemistry was just a little bit off. As she put it, at first we assumed it was a mineral called pyroxene, which is very common. But then we decided to take a second look. And wow, that second look was the pivotal detective moment. Through follow-up analyses, they confirmed they absolutely weren't looking at ordinary pyroxene. They were looking at andesite, literally the very first discovery of garnet in a Martian sample.
Section 2. Decoding the fruitcake meteorite.
To really appreciate this discovery, we need to zoom out to the actual rock that carried it all the way across the solar system, NWA 8171. Technically, this is a basaltic breccia. As a geologist, I absolutely love this term. It basically describes a type of rock that forms when ancient magma cools, hardens, and traps other distinct blobs of mineral and rock fragments right inside it.
So think of this meteorite as a giant geological fruitcake. The basalt, that ancient cooled Martian magma, well, that's your dough. And the diverse mineral inclusions trapped inside, including our tiny green garnet, those are the fruits and nuts scattered throughout. Between the magma dough and these diverse little mineral fruits, this entire rock has a massive amount to say about Martian geology.
Section 3. Nature's Geological Storytellers.
Now you might be wondering, why are planetary scientists so incredibly excited about a tiny piece of garnet? Well, the crucial point here is that garnets aren't just pretty rocks. They are exceptional geological time capsules. They're superb storytellers. First, they retain these perfect snapshots of the exact temperature and pressure conditions under which they formed. Second, scientists can actually use them to date the timeline of those ancient conditions. And third, they often contain traces of surrounding chemistry from when the garnet was born. Basically, they record the history of the entire planet around them.
Section 4. Rewriting Martian history.
Because this tiny grain is such a good storyteller, we have to listen to what it says about deep Martian evolution. The catch is, the right set of conditions to form garnet has never actually been identified on Mars before. Here on Earth, garnet is a classic example of a mineral found in metamorphic rocks. It requires extreme metamorphism, meaning it needs exposure to intense heat, high pressure, or hot fluids to transform. On Mars, though, researchers theorize that the intense heat and pressure needed to cook up a garnet might have come from a violent meteorite impact hitting the surface, or maybe ancient magma rising up into the crust, or, hey, maybe even a combination of both.
Just discovering that Mars even had environments capable of this kind of intense metamorphism is huge.
As planetary scientist James Darling from the University of Portsmouth said, the findings add a striking new dimension to our understanding of the geology of Mars. He hits the nail on the head there. This single, tiny grain opens up an exciting new window into the geologic processes that were historically possible on our planetary neighbor.
But, as with all great science, there's a catch, and a lot more work to be done. The final test awaits: isotope ratios. Remember our fruitcake analogy? Because this Brescia meteorite is a mixed bag of materials, researchers can't immediately rule out one wild possibility. What if this garnet fragment didn't actually form on Mars? What if it originated somewhere else in the solar system, hitched a ride on a separate meteorite, crashed into Mars, and then got baked into the Martian fruitcake? To solve this, scientists now need to test the isotope ratios in the mineral to see if they actually match known Martian signatures.
So the investigation is very much ongoing. Did this microscopic storyteller actually form in the extreme fires of ancient Mars? And if so, what forgotten secrets of this dynamic, violent, and fascinating planet is it about to tell us? The fact that a grain smaller than a poppy seed holds the power to reshape our understanding of an entire world, that is exactly why science is so thrilling. Thank you so much for joining me in the lab today. Keep your curiosity sharp, and I'll see you in the next explainer.